Hi, this video is about string similarity joins, an experimental evolution case study for liquid benchmarks. There are a couple of available implementations of string similarity joins. A string similarity join is an important operation in data integration and cleansing that finds similar string pairs from two collections of strings. So there are a couple of implementations such as list merger, all pair, ed join, qchunk, adopt join, vchunk, pass join, partenum, fastss, tree join, m3, pp join. Benchmark setup. In order to run an experiment with string similarity joins, we need to have a couple of datasets. There are three type of datasets for strings, which are short strings, middle length strings, and long strings. And for tokens, there are small token number, middle token number, and long token number. Benchmark setup. There will be two metrics in order to compare between our experiments. One would be the running time and the other candidate number. So it's demo time. So let's have a demo. After logging into the Liquid Benchmark platform, we need to create a new subdomain for our new test experiment. So we go to our test domain and right click and add new subdomain. We call it string similarity join. We can add a description, but it's not mandatory. So we click on save. We have string similarity join here. Open that up. The system automatically creates all these components which we need to provide for Liquid Benchmark platform in order to run an experiment. So we start from inputs. Right click on inputs and add new parameter. So the first parameter would be DAU. It's an integer, and optional. Save, and we have DAUE. Another parameter is dataset file URL. The type is URL and it's optional. So the third one is called Q, and it's integer and it's optional. The reason I'm ticking the optional field is because we will be adding a couple of different algorithms which they are not sharing a single parameter which they must use, or all of them must use that parameters are. I'm taking the optional parameter which gives me the flexibility of ticking any of the parameters which is needed by a particular algorithm. So now we need to add type. It's text and again optional, and delta. It is integer and optional, and a method and optional. So these are all input parameters. So let's create an output. I just put time. Okay, we have inputs and an output. I just close it in order to have more space here. So I want to define a sample algorithm. Right click, add new algorithm, and title. So tree join E, and you can add a description if you want, but description is not mandatory. Service path is this, and the dataset file URL is mandatory for this algorithm in order to be run. So when we define a new task, we must provide value for these two parameters in order to be able to run an experiment on this algorithm. So hit on save. We have this sample algorithm which we just added. There are a couple of other algorithms. In order to save time, I'm gonna add all them in here and pause the video, add them here, and we'll come back again. So now we have all of the required algorithms in here. You can see all the list of the algorithms. So now I just want to close that down in order to have more space. So we have defined inputs, outputs, and the sample algorithms. And now it's the time for computation environment. So right click on computation environment and add a new computation environment. I want to call this computation environment a string CP1. And the size, I just want to choose the second size, which has more RAM, and the image ID. Here is the image ID for that computation environment. What the image ID means when we create a virtual machine on Amazon and we deploy all of the web services which are presenting the algorithms, and then we create an image based on that virtual machine, and that image has an ID. So we will be using that image in order to create a new virtual machine and run our experiment on that virtual machine, and later on we will destroy that virtual machine. So this is the computation environment. So now let's create a task. We will need two tasks in order to run this experiment. So one task will be for normal string similarity join algorithms, and the other would be for token based ones. So I just added a token word in the end of all token based algorithms. So we will need a different task because the inputs are, the data sets are different for these two kind of string similarity algorithms. So now let's create the first one. Right click on tasks and add new task. I'm calling this task for string similarity, and I just want to leave it private, and type would be 2, dataset file URL is this, and the Q would be 3, type is gram. So let's save it. Alright, enter a number for delta, so it has to be 0. Okay, so we have the first task and we need to add another task. I just put task for token based. So in here, type would be 2. Here is the difference because the dataset file URL would be different for token based. As you can see, I just put token.bean for this dataset, so this is different. So we can't run the exactly same dataset on both of the algorithms. So the Q would be 3, type would be 0, delta would be 2, and method would be this, and let's save it. So now we have two tasks on computation environment, couple of algorithms, one output and the inputs. So now let's create an experiment. So in order to create an experiment, we need an output parameter, which would be time. So I'll add it to experiments, and we need algorithms. So I'm going ahead and adding algorithms one by one. I just want to have all of them possible. So pass join, fast all pair, join, chunk, and adopt join. And I would like to. So I'm leaving token base because they need a different task. If I put them all together, they will share the same task, and it won't work. So let's go and ahead and add the computation environment. So that's the computation environment and the task. So that's it. So let's add them to the queue, and I just want to have them public. So everything is detected, everything is fine and okay. So the system tries to create experiments, and if we get the previous attempts, we should be able to see the tasks which have been created automatically by the system, and the status of all of them is pending. And we can see the user is admin user, which is what we logged to the system by that user. And you can see the computation environment algorithms. So all of the algorithms, they have separate experiments in the system. So this ID 194 to 201 would be our experiment. So, and we can see 194, and we can see in the output panel all of them have been added. So I'm gonna pause the video and wait for the system to run all of the experiments, and then we will come back and try to see the results and draw a graph based on that. So I'm pausing the video now. Okay, now all of the experiments have been finished. If we check the status, we can see they are all finished. So we can check the details of each algorithm. So I just move the screen to the left, then we can see better. So if we click on details, you can see here the output, so input and output. One of the parameters which we are concerned about is time. So this is the time which took for the algorithm to run using those input parameters which we provided in past. So this is the time, and it's based on milliseconds, and these are the other output parameters. So we can check another one as well. We can check this. So this one took 14 seconds around. So let's draw a diagram and see how we can compare these all together. In order to select all of the algorithms, all of the experiments, I just click in here. So all of them are checked. So let's draw a chart. Draw chart. I would like, yes, I'm happy with pi chart, and metric is time. Metric comes from the output parameter which we chose when we were running our experiments. So okay, so we can see the comparison between execution time. You can see it's very clear that some of the algorithms took much longer. You can basically go over each algorithm, each part, and see exactly how much it did take to run that algorithm, and the percentage if we compare all them together with the same input parameters. Also, we can get the image as well, or download the CSV file. Then we can use the information for our own purpose in Excel and or other software. And also we can download the PDF as well. So let's try another chart. So we go with column chart this time, and we can see all pair ED took the most, so it's 692 seconds, or 692,287 milliseconds, and fastest ED is the minimum one. So this is another way of comparing all these algorithms. Let's try another chart type. We choose line chart, and this is the line chart. So we can see again fastest SSD is the lowest, or maybe try 3 join ED is the lowest. Maybe yes, rejoin ED is the lowest. So basically it's the best way of comparing all these algorithms by drawing a chart, and it gives us all the information for the chart as well. So let's try to run another experiments for token based algorithms. So what I'm going to do, I'm going to delete all these experiments because I don't need them anymore. So delete. So they're all gone, and now we are going to create new experiments. So so we go to experiments, and okay, output parameter would be time. So select time, and for algorithms I'm going to use token based algorithms. They require a different task which we have already created. So we have 5 token based algorithms. We use the same computation environment, and for task we will be using token based one. So that's the task. So let's add that to the queue, and okay, everything looks fine, and it's just doing a couple of checkings. And if you go to previous attempts, you should be able to see, yes, we have 5 separate experiments, and the status for all of them is pending. So what I'm going to do is stop the video and wait for the system to run all the experiments, and we will have a comparison later on then. Okay, now all of the experiments have been done, and we can see the status is finished. So we can check the results by, I move the screen by going to clicking on details here. So we can see like the input parameter and output parameter. This is only 1 millisecond, took another one the same, so it's very fast spin, but and this one is too. So the input parameter that I have provided for this was, the file was very small, so it didn't took much. However, we can have a comparison, so let's compare all of them and draw a chart, and let's go with column chart. And okay, and we can see all of them took the same, and except Parthenon tokens that took much longer, it's 2 milliseconds. So, and I can have basically another comparison, so like this. And let's say I'm not happy with the input parameter for this experiment, so I want to leave a comment. So I click on comment and write a comment, and I will say the input dataset was too small, and save. So when another user comes to the system, and if this experiment is public, so he can click on comment and see what I have put so far.